We're live. We are live. Do we have an audience? I can't see because I followed the correct link. It's so sad.
It takes time. Although it's good now, I've definitely follow my instincts here, and I wait to see that there's actual viewers, and I wait to see comments in the Q&A app coming in before I actually press the start button, because it just goes wrong, and then people miss the beginning of the show, and sometimes it doesn't even record. But I see 3 viewers, so now at this point people can see us. So I'm gonna say hi to Richard Clark, Guido Bibra, Thomas Traniker, Matt Woods, Michael Thompson, Giselle Severin, Cameron Membry, Michael Collins, Tom Nathy, Susan Hunter, Rick Schwartz. Wait a minute. Stephen Walker, Nancy Graziano, Bob Harkins, Helg Bjorkog, Hugo Burnham, Michael Collins, not the astronaut. Well, maybe the astronaut. I don't know. Hello, everybody, and welcome to today's episode of Astronomy Cast. I'm pretty stoked, I gotta say. When you think about it, 400 episodes.
Oh my God.
How on earth did we have the commitment and consistency to produce 400 anythings? It's crazy. Actually, it's crazy. Universe Today's got 21,000 posts in it now.
Oh, jeez.
Yeah. Wow. It's like, I did the math. I write a novel every about 4 months or so.
Yeah.
Right. Which is
at least you don't have to worry about plot inconsistencies, because the scientists.
No, I know. Very short little stories based in reality. So no, it's true. I don't have to really kind of deal with the anything longer. I don't ever want to anyway, because I've written books. It's not fun. It is awful. And anyway, so a couple of Universe Today folks are working on some books, and I don't envy them. No. I saw what it did to Amy. Just tore her apart. So,
and now Nancy's writing one.
Nancy's working on one, and Bob is working on one. Yeah. And I don't hear or see them anymore. I just can't talk writing. That's the gist of our conversations. So yeah. So there you go. What else to say? So if you have no idea what it is that you have stumbled upon.
How did you miss 400 episodes?
Welcome to Astronomy Cast. Welcome to the 400th episode of Astronomy Cast. So we're going to do the show, and we'll stick around and have a party with you guys. So we'll answer your questions and just hang out and yak and talk about the future. And I hope that this won't be a thing that we wait 400 episodes for the next time that we do this.
What's funny is, as we approach the 100th episode, we're like, we should plan something special, and then we never plan anything. When we hit 250, we should plan something special. We never plan anything special.
Yeah.
And we seem to have finally at 400. So I guess, I have no way to explain that one.
Yeah. Well, I'm not a very sentimental person anyway, so I tend not to really, even notice that I'm having a birthday, things like that. So people are like, are you going to do anything special for the 100th episode? I'm like, nah. Your
wedding was the best example ever of that. Yeah, I just finished recording the weekly Space Hangout. I'm going to go get married now.
I'm going to get married now. Yeah. Yeah. Well, the second wedding, don't take it quite as crazy as the first one. Okay. Well, I think I'm ready to do a podcast now.
Stuff and things. Okay. I am, pressing record.
I have also pressed record, and it is recording. Hello, Preston.
Hi.
Okay, here we go. Astronomy Cast, episode 400, The State of the Universe. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today. With me is Dr. Pamela, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Happy 400th episode.
Yay! It's really kind of amazing that we've been able to do this, and so many people have come along with us for the entire ride and have been there supporting us through messages, through donations, through wearing our t-shirts. That's actually kind of my favorite thing, is to see an Astronomy Cast shirt in the wild.
It's amazing. We started in the fall of 2006.
Yeah.
Where I wanted to, people don't know the story. I wanted to start a podcast. You were already doing a podcast. I pitched the podcast to Phil and he said, that sounds great, but I'm super busy. Phil Plate, but he's like, but I know Pamela's got some time and she's awesome. And I'm like, who's this Pamela person? So I've listened to your show, listened to Slacker Astronomy, became a total fan. And then Phil was like, Fraser, Pamela, Fraser. And then we talked. And I think within days of having that first conversation, we had already recorded our first show. And here we are 7-8 years later.
Yeah, we talked,
9 years later, still going strong.
August 18th or so. And then we launched our first episode either the last Monday of August or the first Monday of September. And have just kept going. Yeah.
And it's great. And, now podcasting is cool, but, we've been podcasting for a while and we're just waiting for everybody else to catch up as we do. And when you think about over time, right? Like, it started as a very, it was a private audio Skype show that we recorded. And we then with Hangouts pushed it to being something that we do, publicly, where our fans get to hang out with us and we talk to them and answer their questions, which is great. A little stressful, but great. We started CosmoQuest. Right. All the stuff that's happening with Astrosphere, Cosmo Academy, all of that stuff that's been going on, and some highs and lows with that.
Sequestration. We survived 2 government shutdowns. We survived for people who don't realize the scale of what happened when the sequestration bills hit in 2012, our non-donor funding went down by literally a factor of 10 in about 4 months.
Yeah.
And that was brutal. Yeah. And I'm happy to say that we have been awarded from NASA funds. There will be a full press release coming shortly, but I can safely say, since NASA's press release is already out, we are going to be not just at pre-sequestration funding, but we are funded to grow and thrive. And I will have job postings. So if you want to work for me and live in the middle of the country, I might just need you.
Yeah. And that just shows like how seriously, NASA and stuff take the kinds of education and outreach and stuff that's going on via the internet. We knew that what we were doing was of value, but I think, a lot of other people thought that the traditional way of reaching out via press releases, via conferences, things like that was the way to perform education and outreach. But we knew the internet was the way, and now NASA is dominating and the internet. They're doing a really great job of it, and they really support now the stuff that we're doing. So it's fantastic. That's all crazy.
We pioneered with that NSF grant that we had live blogging from conferences back pre-Twitter. There were days before Twitter. That's shocking.
Yeah.
And now conferences are like partnering with people to microblog the entire conference, and that's amazing.
You had a job as a professor at Edwardsville. Still do.
I still do. I shifted around. You shifted around.
I was the publisher of Universe Today, and I still am. So again, I held a job for a long period of time. I had a 3 and a 5-year-old when we started.
Yeah, and now you have a 12 and a
14-year-old. Yeah, which is crazy.
I shouldn't embarrass Logan, but the first time I met your youngest son, he was still periodically wetting the bed.
Oh, poor guy. Yeah. And let's see. And I got remarried. So it's been, but you still got the same.
I didn't have a horse. I had a horse. I had a horse that tried to kill me. I sold that horse, got a different horse that did not try to kill me.
Yeah.
Retired him so that he is now the grumpy old horse that chases around the baby horses and doesn't have to get ridden by me. And am now looking for a horse again.
Wow. And the space community, I think, is one of the things that's changed the most over these years. Like, it's just really, it's everywhere. A lot of the people that we've been friends with for a long time have become really successful, and it's just great to see.
Ian O'Neill.
Yeah, Ian at Discovery.
Yeah.
Into her title with Discovery and writing her own books. Brian Coberline, Phil Plait, obviously dominating. Right. Neil deGrasse Tyson, who we hung out with. He
was already dominating.
He was starting to become popular but he still, we could hang out with him at a.
I think we
at
could
a
still hang out
AAS.
with him.
Maybe we still could, yeah. So I think it's been crazy, and here's to another 400 episodes. And I promise we won't wait this long until this happens again. So now I'm going to sort of focus here for a second. I'll do my official intro. So here we are, 400 episodes after starting Astronomy Cast back in 2006. And in that time, we've learned a tremendous amount about the universe around us. It's time to take a second and consider how our knowledge of the universe has changed since we began this show. Now, we are going to go all over the place, mostly by our collective excitement. So I think let's just start with water.
It's everywhere. It is insert expletive everywhere.
Yeah. When you think about, like, I don't know if you ever read, did you ever read The Case for Mars by Bob Zubrin?
No.
Okay, so in this book, he's the one who really sort of pushed forward this idea of, living off the land, sending a spacecraft that goes and makes fuel on Mars, and that's how the astronauts are getting home. And that was the plot of The Martian and things like that. And that's really NASA's, the way they're planning to return to Mars. And in that book, he was like, we don't know if there's any water on Mars. And so we may need the rocket to take its own hydrogen. And that once on Mars, they'll then use that hydrogen to make rocket fuel and water for the astronauts and so on. No problem. There's water on Mars.
And what's amazing is the number of different ways that we started pre-Phoenix. We are post Spirit and Opportunity, and Opportunity is just going to keep going forever.
Yeah, it'll
outlive us all.
Yeah.
But little Phoenix flew, landed, tweeted with fabulous empathy, dug up ice, watched it sublimate, and was the start of, yes, there is water on Mars. And since then, we have identified that the dark streaks are definitely briny liquid. And we now have entire regions of thou shalt not pass for Curiosity and Opportunity, because we don't want to accidentally kill life on Mars.
And not only is there water now, but there was water in the past.
Exactly.
In the ancient past, this was discovered by Spirit and Opportunity, like just after before we'd started the show. But Curiosity helped turn up that water had been active on the surface of Mars for long periods of time in the ancient past, which is just what you want for potential of life. But Mars is just one place. All of these icy moons, like Enceladus, we're seeing just so much water on them now.
And
the surface.
Mercury. Mercury snuggled up next to the sun, so close that it's getting atoms blasted off its surface by the incident ions. Little Mercury has water. Yeah.
Vast amounts of water on the moon, both in sort of these craters in eternal sunset and eternal shade, as well as just like under the regolith on the moon. And again, this is all, these were all discovered within the last decade.
But on the other side of that, we now know that all of the water on Earth probably didn't come from comets. So the science giveth and the science taketh away. We no longer quite know where our water came from.
Saturn's rings, if you'd asked us back when we started Astronomy Cast, how old are Saturn's rings? The question is, we don't know. They could be old, but they also look new. And within the last couple of years, astronomers now know that the rings are old, but they look new.
Which is one of those kind of tricky things. Now, before you start sending the hate letters, we do fully understand that some of those rings are getting refurbished by geysers and things
Mm-hmm.
like that. But overall, the constant collisional kinematics, dynamics of those rings, this is what builds them up, breaks them down, and gives them those nice, shiny, new-looking surfaces. And we now are starting to understand that.
When we started, was there such a thing as a dwarf planet?
It existed as of the week we started.
As of the week we started. Okay,
Yeah,
well then never mind.
that was our very first episode.
But it wasn't, I mean, so Pluto became the first, and I think in Ceres at that point were considered the first dwarf planets. But after that, a bunch of other dwarf planets were added.
And we now understand that, like, Haumea is this really weird spinning thing with a moon that we can't understand. And in fact, as of just last week, again, with the giveth and taketh away, Pluto killer Mike Brown at Caltech, one of the far too many Michael Browns out there. So we'll just call him Pluto killer.
Pluto killer Mike Brown, yeah.
Right. So he found all of these interesting things, Eros being the biggest of them at that point, that are now being understood to have weirdly chaotic orbits that aren't actually chaotic. They seem to be dictated by a high mass object that we're now calling the new ninth planet.
That's and maybe in 100 episodes we'll have it'll have already been either confirmed or the evidence will mount against it. But speaking of dwarf planets, we saw imagery of Pluto up close from New Horizons, which has got to be almost my highlight of the entire run that we've been doing this show.
And maybe in another 100 episodes we'll understand how the heck we ended up with a brand new surface on Pluto.
Yeah.
Pluto should not have a young surface. It's highly confusing. So give us 2 years and maybe we'll have hints, but probably another 400 episodes to actually understand it.
I love to ask space scientists, mission planners, like, what are you expecting to see when your mission goes to this world? And the answer that I love to hear them say is, they'll say, like, we're looking for the magnetosphere of this and the surface composition of that and the aging, the craters of that. But the thing they're really looking for is the big surprises, the stuff that they had no plans for. And with the new imagery of Pluto and Charon, it's all kinds of surprises.
And speaking of spacecraft, we've seen Hubble not get decommissioned, but actually get refurbished. And that's a spacecraft that was originally built under the justification that it would solve the expansion rate of the universe, which it didn't quite do. We needed, like, the Wilkinson microwave anisotropy probe. But because of it, it was supposed to figure out planetary nebula, and sorry, Preston. It didn't only help us understand planetary nebula, but it pointed out so many things that we had no clue of. And one of the coolest things that it brought us was the realization that, as you put it, as we were prepping for the show, dark matter is stuff and gravity is not bad. And not bad gravity is how you said it, which was far more cool.
What did I say? Dark matter is stuff and not gravity.
Yeah. Bad gravity is how you put it.
Oh, did I?
Yeah.
Right. Yeah. So this idea, right, that now we're fairly certain, and by we I mean astronomers, are fairly certain that this mysterious dark matter that they clearly see out there, or through its gravitational interaction, clumps. They've found whole galaxies that appear to be almost entirely only dark matter. They've seen how galaxies can collide with each other, and then the dark matter sort of passes right through with the stars, but the dust and gas collects in the middle and starts new star formation. So they've really started to understand the scope and scale of dark matter, but they still don't necessarily even know what it is. So I look forward to that being a thing that we can finally, stick a, pin in and call that one done. Although, whenever I ask astronomers, the answer that I'm getting these days is, I think it's a particle with a very small cross section.
Right. And the fact that we can start to identify the characteristics of the stuff that the dark matter is, we now know it's not Acme bricks. It's not white dwarf stars. It's none of those things that Macho was looking for. But we are starting to say, okay, we need to justify growing up the Large Hadron Collider so that it can do higher energies. We need to expand Fermi National Labs so that it can collide at higher energies. And as we've worked on these higher energies, we got to witness, not firsthand, but through the media, the discovery of the Higgs particle. And that was really cool.
Yeah. I mean, that's a whole other, that was one of those things. I mean, that's classic, right? That back in the 60s, Higgs and team predicted the existence of the Higgs particle, this particle that would, provide mass, help explain mass in the universe. And bigger and bigger particle colliders had to get built to the point that they could actually detect this particle. And it was only within the last 2-3 years that they finally nailed it down and confirmed the existence of the particle, which is just amazing.
And it's been amazing to cover it, from everything from the baguette that broke the world, basically, that stupid bird dropping a baguette and breaking everything, to just well, if you haven't watched the movie Particle Fever, go watch it. It explains everything. But it's been amazing to see from the sidelines the struggle to make some of these discoveries.
And then, of course, hopefully in the next decade, it will turn up all kinds of new particles and maybe even confirm
or rule them out,
or confirm supersymmetry, maybe detect the actual particle that causes dark matter, maybe create microscopic black holes as predicted by Stephen Hawking, and see them evaporate. So, this journey has only just begun. What else? But we've been talking about all these things that have changed, all this new information that we have. Dark energy, I would say
we still know nothing.
We don't know anything else. Like no.
We have a noun.
I think we mostly are probably pretty sure that the big rip is not going to happen, probably. That's about it. It doesn't appear that the expansion of the universe is accelerating. The acceleration of the universe is accelerating. But apart from that, no, we don't really know what it is. But we do know how old the universe is.
And it changed.
Yeah. Yeah, we thought we knew, but we didn't know.
We knew within error bars, it turns out. We now know that we live in a 13.8 billion year old universe. Thank you, Planck.
13.7.
And it turns out WMAP got it mostly right. It had the error bars. I no longer know the error bars. They're evolving. But we used to say it was 13.7 plus or minus 0.2 billion years old. We now know it's 13.8 with smaller error bars that Pamela can't remember.
Yep.
And that's been cool. And we've had lots of mysteries to chase down with the cosmic microwave background, because there was the cold spot discovered that we still don't understand, but there's been lots of crazy theories.
Yeah, crazy theories, like other universes bleeding in, all kinds of stuff. So, oh my God, what was I going to say?
Light echoes. I'm just going to go there. I'm going to say we have discovered light echoes from everything.
I was going to mention one thing that we thought we discovered. And if we'd done the show a couple of years ago, we would have thought that in the cosmic microwave background radiation had been discovered evidence for primordial gravitational waves, confirming inflation.
But it was wrong.
But it was wrong. So what have we learned? Right? We've learned that science is hard,
yes.
and that dust inside the Milky Way can maybe cause you to think that you might have seen primordial gravitational waves in the cosmic microwave background. So be careful.
Dust and magnetic fields continue to be the two things that are hardest to deal with.
So you're talking about light echoes. Sorry, until I.
No, it's cool. So we have discovered that AGNs turn on and turn off, which we knew, but we've now actually seen the evidence of the light echoes turning off. And the Macho Project has revealed light echoes of supernovae in the past, where we've been able to now identify past supernovae in our own galaxy that we knew statistically should have happened, but weren't seen by anyone interested in putting it into the archaeological record. And so we've been filling in the history of our own galaxy one light echo at a time.
We've watched stuff fall into the supermassive black hole at the heart of the Milky Way. Stars, gas clouds, maybe stars.
Probably not stars. I'm going to go with the gas clouds.
Maybe. I have it on authority. But still, we've watched things of mass get torn apart by the supermassive black hole at the heart of the Milky Way, and sort of let out a scream as it died. But then, for a future state of the universe, we still haven't actually seen the event horizon of a black hole, but there's a ground telescope in the works, the Event Horizon Observatory, that will help us do that. So, that'll be a future.
And just to be clear, you don't see the event horizon. You see the stuff that is suffering the event horizon.
Yeah, the edge of the event horizon. What's happening right at that environment around the event horizon. But that's for the future.
Science fiction movies would be so much less interesting if event horizons were politely marked so that you couldn't just kind of wander past them accidentally. Speaking
of black holes, we now know that there are supermassive black holes at the heart of every galaxy.
Yeah. The only ones that escape are the oddball dwarf spheroidal galaxies, which kind of like don't match galaxy dynamics, but they aren't globular clusters, so they're just weird. But ignoring those little dwarf spheroidals of weirdness, there's if you are a galaxy that isn't a wannabe globular cluster, you have a supermassive black hole in you.
And one of the mysteries that we've been hanging on to still to this day is which comes first, the black hole or the galaxy around it. And that still, we haven't got a satisfactory answer to that question. So we're going to stop. We're going to put a pin in that one, and hopefully we'll have a better answer next time we do this.
But we did get a cool answer on our galaxies built bottom up or top down, and the answer is both.
Yeah.
And that's cool.
Speaking of black holes, we still haven't found that intermediate mass black hole for certain.
Yeah. How do you get to the supermassive? We don't know. We don't know.
But you would think that you would see these, we definitely see these stellar mass black holes, like,
they're cool. They're chilling everywhere.
Yeah, all over the place. And you would think that those black holes over the billions of years would have accumulated a lot of material, just gotten more and more massive, especially in places like globular clusters, and turned into supermassive black holes. But that middle range, there doesn't seem to be anything in between stellar mass black holes and the supermassive black holes. There's been a few stories, but I don't think anyone has really out and out confirmed and said, okay, that's it. We've definitely found, and we're finding more of these intermediate black holes. So that's another thing that we, I think if you would ask, that would have been something that we would have expected to have been found by now.
Yeah. Black holes are passive aggressive, not actually aggressive.
Right. Man, what else? Okay. So let's talk about planets. Let's talk about exoplanets. So when we started the show, we did a couple of episodes. Some of the first ones, we did one on sort of just regular exoplanets, and then we did one on some weird ones like hot Jupiters and pulsar planets and things like that.
But Kepler hadn't launched yet.
And the ground-based methodologies for finding planets had not been perfected yet. Yeah, and so here we are now. When we started, there was probably dozens of extrasolar planets that had been discovered.
And when people talked about finding them, they talked about the Doppler shift method as the primary method of look at a star over and over and over again, doing high resolution spectroscopy, lots of difficulty, can only use bright objects because the spectroscopy is hard and you need lots and lots of light to shove down that slit. But then we started launching things like Corot and Kepler, and Gaia is coming, and now the primary way to find them is just watch stars to see if they dim a bit.
Yeah. And so we now know of thousands of planets and the kinds of planets with the mass of the Earth, planets in in the habitable zone of their parent stars, planets with hot Jupiters and planets in weird eccentric orbits, and binary stars with planets, and quadruple star systems with planets, all kinds of crazy multiple star systems, multiple planetary systems with sometimes multiple planets in the habitable zone, super Earths, Neptune mass objects. The list just goes on and on and on.
And what's weird to think about, though, is while we know so much more about whether or not there's planets out there, we still know nothing about the probability of alien life, whether it be intelligent, bacterial, or intermediate. All we know is there's more planets. So I've been saying since we launched that any year now we're going to be able to start measuring atmospheres, which we can do. We started doing that. First half of the sentence was good. Second half of the sentence was, and we will find the chemical signature indicative of life. And so far we haven't, and it's driving me crazy.
But right. But when we are really in the nascent stages, we are to studying atmospheres to what we were to finding planets 10 years ago. And so there are plans in the works to build these coronagraphs, these really interesting new kinds of observatories, James Webb, using some of these other space observatories to assist in this process. So I think if we did this show, 8 years, 9 years from now, 10 years from now, we would have a much better, conversation about looking at atmospheres. We're at the, it's possible to see an atmosphere of another planet on a good day.
And we've seen a major revolution in technology that is still underway. We saw it in 2012. I think it was 2012. ALMA started completely changing how we see things in the longer wavelengths of light. We have Curiosity is a workhorse on One World, but it took a whole mobile lab with us. It's CSI on the Red World. And now we have James Webb Space Telescope getting ready to hopefully start in 2018. And with that 1-2 punch of ALMA and James Webb Space Telescope, we have opened up the early universe and planetary to levels of observation that we just haven't ever been able to do before.
Now, one of the things that I think we would have expected by now was a more robust human exploration.
Yeah, we got that one wrong.
Yeah, we got that one wrong. So I think that next week we should predict. Let's totally do that.
Oh, things I hate to do, but yes.
Oh, that'd be awesome. But I think the stages are coming together. So this big revolution has really been the rise of the private space industry, and especially really driven by what's happening with SpaceX and Blue Origin and with all of these private companies. And that is just, that's proceeded at a pace that I don't think anybody expected.
But at the same time, I was totally expecting that by now we would see regular launches of Virgin Galactic with space tourists. I was expecting Bigelow to be a little bit further along with their space hotel plans. So we're in this weird place where it seems that commercial space at the low to high Earth orbit is chugging right along with its plans. And you're right, it's the folks, Sierra Nevada, Blue Origin, SpaceX. These companies are doing excellent work hand in hand with NASA in a lot of cases. But when it comes to that suborbital spaceflight and commercial tourism, it seems like we're 3 years away, 9 years later.
Yeah. And so then also there's what's happening with the Chinese. So the whole Chinese space exploration really has happened under our watch with Astronomy Cast, going from launching humans into space to launching a space station to sending a rover to the moon, sending an orbiter around the moon, and very definite plans to put humans on the moon in the near future.
And India, without the human space flight, is making amazing progress as a scientific explorer of space.
Yeah, and many other countries as well. So India did a great job with the MOM mission.
Yes.
But then there's other even smaller countries are putting together their own space programs. So I think we're in Europe. I mean, that's not like a smaller country, but Europe has been fantastic with the Rosetta, with a lot of really interesting missions. So I think all the countries of the world are really starting to take this seriously and play a part as well, which is great. It's great to not just have it be an American story. It's a worldwide story now.
And worldwide stories. We have Russia currently launching all of the humans and also getting attacked from space.
Yes.
Right. So go ahead.
Oh, I was going to say, yeah, we learned that we are, remember, in a cosmic shooting gallery.
Yeah, and Chelyabinsk was one of those amazing moments of, wow, they have a lot of dash cams, and thanks science, they have so many dash cams. That, for those of you who don't remember, on Valentine's Day in, 2012?
13?
Or 2013? A lot of stuff has happened over the years. Anyways, the Valentine's Day massacre occurred. It was still Valentine's Day here in the US. I think it was February 15th in Russia. And during the morning commute, it could not have been better timed, a Apollo class meteorite, asteroid that became a meteorite, encountered the atmosphere, plunged through it, exploded over Chelyabinsk, Russia, to be captured by many, many cameras, generated a giant flash of light that attracted everyone to their windows, where they then got attacked by the sonic boom a few moments later.
And we now have pieces of this asteroid.
We do. Yeah. Thank you, Richard Drum. You are awesome.
Cool. I'm trying to think what else we've learned. So a few other things. Did you mention Voyager's left the solar system?
I did not, but it has multiple times, in fact, if you follow all the press releases. But we think it's actually left for good this time.
Astronomers found a ring around an asteroid.
And moons, more moons.
More moons around asteroids. And I think we learned that NASA is very complicated.
Yes, that's true. Another great quote from our prep time was Fraser's, like, our relationship with NASA is complicated. And this comes down to watching so many different things, both with our own funding and just how you learn to communicate about NASA discoveries, from things like there were all the warp drive press releases, and we've both had to explain to so many people that NASA funds people to do exploratory research that are sometimes random university professors trying to do awesome things. And when you see the press release, NASA is working on warp drive, sometimes that just means that it's like random dude who got awesome grant to try something, and that doesn't mean that NASA's leveraging all of its governmental resources to work on warp drive, because really it's not. So
there you go. I think that that kind of wraps up. I'm sure there's, we could go down this rabbit hole and come up with many, many more, but these are some great examples of the things that have happened since we started Astronomy Cast, all of the big new discoveries, all the new things that we know. And it's been a total honor and a pleasure to sort of do this journey with you, Pamela. It's been a lot of fun.
It really has. And it's great to work with someone that, we keep showing up and laughing across basically 10 years, and we didn't even meet for the first year and a half.
Yeah, totally. So let's do that. Next week, I'll queue up a bunch of topics and we'll make some predictions.
That sounds great.
And we'll just make stuff up. So that'll be great. And then
this is the only time that Fraser can make up anything he wants and I can't shoot him down.
Absolutely. And then 100 episodes later, we'll look back and see what else is new and see how our predictions held up.
And just, I also want to say thank you to all of the people who've donated to keep us going over the years. You have paid Preston through his undergraduate and graduate studies to keep being our editor. You helped in our early days, Rebecca Bemrose-Fetter, who was a different student that worked with us. If we get enough donations, I would love to hire another student in the future. There's been, we've gone through a whole series of Nancys. We had Nancy Atkinson, who worked with us for years. We now have Nancy Graziano, who's helping us out. There's Susie. Susie is our new herder of awesome.
Yeah.
We aren't easy to herd.
Yeah, totally.
And shout out to all of the people at SIUE who have supported us, and all of our sponsors. There's Uncle Bob, who has supported us across multiple of his organizations. Swinburne Astronomy Online has supported us over the years.
Casper mattresses have been great. Yeah.
Yeah. We only take sponsorships from things that we believe in. And xe.com, so many good people have helped make sure that we can keep going. And here's to hoping that everyone comes along with us on the same ride for the next 400 years of
400 years. Whoa, robot body.
Wrong units. Sorry. Here's to hoping that
No, let's go with your 400 years. That is my, I like to think long term.
You do want to live forever.
Yeah, I want to live forever. So that'd be great. Robot body.
So yeah, let's keep exploring.
All right. Well, we'll see you next week, Pamela.
Sounds great, Fraser. Talk to you later. And we save. File.
Episode 400. Oh, someone cleaned out the Astronomy Cast directory.
Yeah, I don't know who it was. I think it was Preston. It is awesome.
That's awesome, yeah. Always asking him to do that, so it just happened. And I'll export.
Yep. And it's exported. I think people were excited about our 400th episode because I had to turn off notifications on my phone because I normally just like stick it behind me on vibrate so the mic won't pick it up, and it was driving me crazy going off the entire time. So thank you everyone for making my phone explode, because that does bring me joy even if I do have to shut it off.
I'm gonna pause my Dropbox so that it doesn't try and back everything up.
I should do the same thing.
Okay.
Yay.
Let's see. Thomas Stradiker says, I'm happy that episode 400 got rescheduled. I'm back for some foot surgery and it hurts. Well, hello from Horton, Sweden. Aw.
Get better quickly.
Chris Webb. Hi, everyone. First time live podcast. Love the show. You guys rock. Thank you so much, Chris. Welcome to doing the live show.
Yeah.
John S. asks, we know that stars die within seconds of iron being formed in the core, and we know that nickel iron is part of the cloud that forms new stars and planets. So how does a star ignite when it already contains iron? Ooh, can I answer this one?
Go for it. I want to see how you get it.
The myth is that iron is poison for stars, but iron is not poison for stars. Iron is like fiber. So stars can't use iron to fuse the way the human body can't use fiber. You need food. So if all you've got is iron, then you're not going to be able to get a star. But if you've got other stuff like hydrogen and all that around, the iron's just going to sit around hanging out while the actual fusion process goes on. And in fact, there are dozens of Earth's worth of iron inside the sun right now, and it just doesn't matter, So you can't, you're not going to die from eating grass unless you don't eat any other food, and then you will die. But if you eat lots of grass, but you also eat regular healthy food, then you're just going to go to the bathroom a lot. So I actually did. And that's what happens to stars. So I
I'm sorry, but you just gave a new definition to explosive diarrhea. It's a supernova event. Sorry.
Yeah, so it's not gonna explode as a supernova unless you've got the actual conditions of the star. You've got to have the, all of the surrounding shells, and you've got to have that, that middle part, and then it's got to stop having the outward light pressure, and then all the outside layers collapse inward, and the thing goes kaboom. But anyway, so I did an episode of this called "Does Iron Kill Stars?" on my YouTube channel, so you should watch that.
So I'm going to go ahead and share this. There's a press release coming, but I just got the official letter from NASA that we're getting $11.5 million for CosmoQuest.
How much?
11.5 million.
11.5 million. How many?
5 years.
How many?
5 years.
Is that for each of us?
None. It's funding like no. Yeah. So I'm still not full-time salary on this, but we're going to be hiring 4 positions here at SIUE, 1 position at Youngstown State University, and this keeps a lot of people who died in the most recent round of funding cuts fully alive.
Yeah, I've never taken a salary from CosmoQuest, from Astronomy Cast. My job is Universe Today there, and so that's how I make my money. So I do all of this purely for the benefit of science.
I do need to pay my bills, and CosmoQuest is my job. But
but you do all the hard work while I just get to show up and
no, Susie does.
Right. I get to just flit about like a tornado, and okay, so Michael Thompson says, last week I attended the Origins Project panel talk at ASU with Lawrence Krauss, Kip Thorne, and others. Lawrence Krauss tweeted about a possible LIGO discovery, but Kip Thorne was very sure not to say anything about that. Do you know if there's any? So the question is, have there been gravitation? Is there direct evidence of gravitational waves discovered yet? The answer is
no.
The answer is the rumor mill is churning, and and apparently a lot of people in this field have cleared their schedules for sometime next month, but there's no concrete announcements yet. There's no one has said for certain that gravitational waves have been discovered, which if they are, right, this is the final confirmation of Einstein's predictions. So it's a big one.
We already had clear evidence of gravitational waves from I believe it was the 98 work on binary condensed matter objects. We just haven't had a wave passing through the planet Earth that we've detected.
Right. We see them indirectly by binary pulsars, but yeah. So didn't make the cut for this episode, but let's hope it makes the cut for. I'll add that to the predictions. Will gravitational waves be discovered? Hugo says, big shout out for Preston too. You're the producer from another planet galaxy, Preston. So Preston is our editor. Susie's our producer. Yeah.
But they're both awesome.
Hail to them both.
Yes.
Astronomy Cast just squealed, oh my God.
I noticed that.
CosmoQuest.
I'm thinking that was Susie.
I think it's Susie, yeah. Sometimes Susie is me. Sometimes Susie is Astronomy Cast. It depends on which show she's producing.
Yeah.
She has to log in as that account, and then
it's the who am I right now, and should I be tweeting as this person?
Beth Johnson says, congratulations on 400. You were one of my gateway drugs back into science, and now I have a BS in physics and an awesome job, and I'm getting ready for grad school.
Oh,
crazy.
That's so awesome.
You're responsible for a chunk of my excitement. How cool is that?
Yeah. So one of the things that
amazing.
One of the awesome outputs of the show was back in 2008 or so, Nicole Gallucci, who was a baby graduate student at the University of Virginia, came up to us at Dragon Con and was talking about how she listened to our show as part of studying for the quals. She got her PhD. She worked for CosmoQuest for 2.5 years, and now she's tenure track faculty. We reproduced.
Yeah, it's madness. And there's a bunch more too. I mean, you can see this next round. Sondi, Morgan, a bunch of them are, this time I'm sure Sondi's going to be the primary investigator for some space mission, and Morgan as well, some ring mission. Nancy Graziano says, congratulations. Thank you, Nancy. We literally couldn't do this without your help. So thank you so much for all your help. You are the greatest. Nancy Graziano is, of course, one of the leaders of the WSH crew, which is the community one of the communities that helps out with the weekly space hangout, and is the moderator for the Astronomy Cast group, which is apparently a thing.
Yes.
Richard Cox, happy Friday from a blustery Toronto. This time jump to Fridays is a bit different, but okay with it. Have we time jump to Fridays? Everyone says, happy 400th episode. Thank you for all the dedication, all the science. Here's to 400 more. Matt Wood says, I remember the Chelyabinsk meteor. I turned up my computer speakers to listen to music while I cleaned the house. Later, I forgot the speakers were loud and came back and played the video of the meteor, and the sonic boom shook the house.
Oh,
awesome.
Cool.
Yeah, that's hilarious. Lucky it didn't blow out all your windows like the poor people in Russia. Nancy said, you are responsible for igniting my interest and propelling me down the social media path on which I now travel. This is Nancy Graziano again, you are a networking genius. So,
and and all of the weekly space hangout people who've come up and helped with us so many ways. I have been bailed out at more conferences. You guys all know who you are. I think it's at Dust Bunny is one of the people who's helped us a lot as a volunteer at conferences.
Elad Avron said, I was just listening to a random episode last night from around 2011, and you were talking about what a great year 2015 was going to be. It's true. We were probably talking about, 2015, we were talking about New Horizons. 2014, we were talking about Rosetta. Yeah. Matt Wood says, congratulations on getting so much funding. It's definitely down to you and your team's hard work. I think the great part is that we're all so cheap. We've been taught to be such, because we ran, you ran Cosmic Quest on an absolute shoestring, tens of thousands of dollars to run with your team, keep everybody rolling.
There's going to be order of 55 people working on Cosmic Quest, paid people, thanks to this funding.
Amazing. Michael Jobin says, can we say oodles of planets? I think that's the appropriate scientific term, oodles of planets.
There's a murder of crows. We need the equivalent for planets.
Yeah. Hugo Burnham says, the most amazing thing to me is how Cassini has outlasted even Astronomy Cast. Without it, we know next to nothing about Saturn, Titan, etc. Absolutely. Let's see.
We've seen Fraser get rid of the stupid colored wall behind him.
I painted my house white.
Glad.
Yeah.
So glad.
Thomas wants to know, what is it with astronomers and animals? Phil and his goats, Pamela and horses. Yeah.
It keeps us sane. Large mammals don't let you wig out.
Yeah, and now I've got dogs. So, right? And Carla would love to have goats or something like that. I mean, she would, we're not allowed to have them inside the city. But I think within the next couple of years, we'll probably move outside of the city and then she can have all the goats she wants. Tom Nathy says, and then there is the fall of the Russian space program. Basically, it's just a platform for launching rockets with other people's probes on them. That's true. It's sort of kind of sad when you think about the state of the Russian space plans. The longest running, most dependable space rocket systems that have ever been created for getting humans into orbit. And that whole infrastructure is kind of, starting to come apart. Just too bad.
Yeah. Have you seen the photos of the collapsed hangar that still has one of the old Russian space shuttles inside of it?
No, the Buran.
The Burans. It's some really tragic photos because the hangar they were being stored in collapsed.
Susan Hunter says, let's name the new planet so far away for Pluto Killer's daughter, not just Nibiru, please. So what's
Lilith?
Lilith, that's Mike Brown's daughter's name?
His daughter's Lily, but I'd really love to see it named Lilith.
Lilith, yeah, that'd be great. I would be fine with Nibiru, though, because I think that would just be hilarious.
That would just be ironic.
Yeah, I think it would be awesome. I'd love it. There's Nibiru right over there. Now we know where it is, and it's still not coming anywhere near us.
Yes.
Cameron Membry asks, do we think we'll get a breakthrough in our understanding of dark matter this year?
I'm not willing to put it on a time schedule.
No, but we'll talk about it next week. I will ask you to make predictions about dark matter next week.
Okay.
Nathaniel Sanchez says, wow, congratulations. Thomas Traniker says, 11 million cheers for Cosmic Quest. And Pamela, do you want my CV? So I'm sure you're going to get a lot of people wanting.
If you're willing to live in Edwardsville, Illinois, yeah, sure. The difficult part is going to be the living in the middle of the country. If you want a picket fence, I'm the right place to live. I have a picket fence. It's just not white.
Sylvan Westby says, oh my God, the sum of money will surely map all the planets in the solar system. Let's hope.
We actually have projects to study dark energy coming. We have astrobiology programs. We're expanding. It's not just planets anymore. Well, it still is for a while, but it won't just be planets anymore.
Let's see. What else have we got? Thomas Stepstrip says, congratulations on 400. You're my favorite podcasters, my weekly science fix. Greetings from dark and rainy Denmark. Well, thank you, Thomas, from dark and rainy Vancouver Island. And you're kind of...
Stay warm.
Yeah. Is it dark and rainy there?
Here? Yeah. Today? Yeah, today it really is. I have to admit, I broke down and I bought a mountain bike because I've desperately wanted to go outside and do something. And the ground refuses to be dry and snow-free.
So you got a mountain bike. Get in there.
I did get a new bike because my happy little road bike with its little tiny slick tires would cause me to die.
Well, anytime you want to do some crazy riding, come on over here. This is Mountain Bike Central. People spend more on their bikes than they do on their cars here. So, we'll totally go for a ride. Cool. Awesome. Well, why don't we wrap things up? So, hey, thank you to all of you for joining us for these 400 episodes. Knowing that we're helping you guys understand and appreciate the universe better just means the world to us, and it's fuel for our enthusiasm to keep rolling. We're super excited to keep doing this and keep going on this journey with you guys, and we really couldn't do this without you. So thank you.
Yay!
We'll see you all Friday when we do the Weekly Space Hangout.
And I am going to make an effort to be there.
That's all we ask. All right. Thanks, everyone.
Bye-bye.